Hi students, in my earlier video we have learned geometrical significance of a pair of linear equations in two variables. Students, there you have also learned the conditions of existence of the solutions of linear equations. You have learned what are the conditions of existence of the solutions of the equations 1 and 2. Here are three possibilities you have learned. Whenever a1 by a2 not equal to b1 by b2, then the lines representing equation 1 and 2 are intersecting. That is, the lines are intersecting. Students, in this case we say the systems are consistent and have a unique solution. In case 2, whenever a1 by a2 equal to b1 by b2 equal to c1 by c2, then lines are coincident. Suppose it is AB, this is CD. Hence we see lines are coincident and hence solutions of 1 and 2 are infinitely many, infinite numbers, and systems are consistent. The equations are dependent. In case 3, we see a1 by a2 equal to b1 by b2 not equal to c1 by c2. Their lines are parallel. Obviously, the system of equations 1 and 2 have no solution. The system of equations 1 and 2 is called inconsistent. Let us consider the following problem. Check whether the pairs of equations are consistent. Here problem number 1. The pairs of equations are given as 3x plus 4y equal to 1 and 2x plus 5y equal to 3. Students, here what is the ratio of a1 by a2? That is 3 by 2. b1 by b2, that is 4 by 5. And what is the value of c1 by c2? That is 1 by 3. So we see a1 by a2 not equal to b1 by b2 because a1 by a2 equal to 3 by 2 and b1 by b2 equal to 4 by 5. Hence, a1 by a2 not equal to b1 by b2. In this case, the lines representing equation number 1 and 2 are intersecting. Suppose it is AB and it is CD. Suppose they intersect at point P. Hence, the coordinate of P is the solution of the equation 1 and 2. Hence, the solutions are unique. The systems are consistent. Students, whenever A1 by A2 not equal to B1 by B2, the lines representing equation number 1 and 2 are intersecting, and hence the solutions are unique and the systems are said to be consistent. Now consider the pair of equations representing problem number 2. Here we see what is A1, that is 2, and A2 is 4. Therefore, the ratio is 2 by 4 equal to half. What is the value of B1 by B2? Here 3 by 6 equal to half. And what is the value of C1 by C2? That is 6 by 12 equal to half. So we see the three ratios A1 by A2 equal to B1 by B2 equal to C1 by C2. All the values are equal, that is half. Therefore, A1 by A2 equal to B1 by B2 equal to C1 by C2. Then we say the lines are coincident. Suppose it is AB and it is CD. Lines are coincident. In this case, number of solutions are infinite. So, number of solutions are infinite. Hence, the system of equations are consistent. And we say these equations are dependent. Students, here see the second equation derived from 1 by multiplying 2. Hence, the equations are dependent. Let us consider the pair of equations given in problem number 3. Here we see A1 by A2 equal to 2 by 4 equal to half. B1 by B2, that is 3 by 6 equal to half, and C1 by C2 equal to 6 by 36, that is 1 by 6. Therefore, we get A1 by A2 equal to B1 by B2 not equal to C1 by C2. Hence, lines are parallel. That is, it is AB and it is CD. Therefore, the system has no solution. Hence, we say the systems are inconsistent. Let us consider the problem. Find the value of k for which the following pair of linear equations have no solution. 2x plus 3y equal to 5, k plus 1 into x plus k plus 2 into y equal to k plus 3. Students, here the given condition is the system of equations have no solution, that is a1 by a2 equal to b1 by b2 not equal to c1 by c2, that is the lines are parallel. Hence a1 by a2 equal to b1 by b2 implies that 2 by k plus 1 equal to 3 by k plus 2. This implies that 2k plus 4 equal to 3k plus 3. This implies that 3k minus 2k equal to 4 minus 3. This implies that k equal to 1. Now let us find the value of c1 by c2 equal to 5 by k plus 3, that is 5 by 1 plus 3 equal to 5 by 4. Here see a1 by a2 means 2 by 1 plus 1, that is 2 by 2 equal to 1. b1 by b2 means 3 by 1 plus 2, that is 3 by 3 equal to 1, and we get c1 by c2 equal to 5 by 4. Therefore we see a1 by a2 equal to b1 by b2, because both are 1, not equal to 5 by 4, that is c1 by c2. Hence when k equal to 1, the pair of equations have no solution. Students, let us consider the third problem. Given the linear equation 2x plus 3y equal to 7, write another equation in two variables such that the geometrical representation of the pair so formed is intersecting lines, parallel lines and coincident lines. Students, here given one equation 2x plus 3y equal to 7. Suppose it is equation number 1. Now let us construct an equation which is intersecting to 1. Here see the point 2 1 lies on 1, because if we put 2 into 2 plus 3 into 1, this equals to 4 plus 3 equal to 7. Therefore we see left hand side equal to right hand side. Therefore the point 2 1 lies on the straight line representing the equation 1. Now let us construct another equation which also passes through the point 2 1. Suppose the equation x plus 2y. So we get it is 2 plus 2 equal to 4. So consider it is equation number 2. Here see the point 2 1 also lies on the equation number 2, because 2 plus 2 into 1 equal to 4. Therefore left hand side of 2 equal to right hand side. So equation number 1 and 2 are two intersecting lines, where a1 by a2 equal to, it is 2 by 1, that is 2, and b1 by b2 equal to 3 by 2. Clearly a1 by a2 not equal to b1 by b2. Hence we see equation number 1 and equation number 2 represent a pair of intersecting lines. Now we have to construct another equation which is parallel to 2x plus 3y equal to 7. Students, in this case a1 by a2 equal to b1 by b2 not equal to c1 by c2. So we can construct the second equation is 2x plus 3y equal to, suppose it is 14. Clearly a1 by a2 equal to 1, b1 by b2 equal to 1, but c1 by c2 equal to half. Hence these pair of equations represent parallel lines. Now we have to construct coincident lines which is coincident to 2x plus 3y equal to 7. Here the equation is 2x plus 3y equal to 7. Suppose it is 1. If we multiply both the sides by 2, we get 4x plus 6y equal to 14. Suppose it is equation number 2. So we see the ratio a1 by a2 equal to b1 by b2 equal to c1 by c2. Since the second equation is derived by multiplying 2 of equation number 1, hence 1 and 2 represents the pair of coincident lines. Students, the problems discussed here are very important in your studies. So I advise you to follow the video from beginning to end to learn the problems properly. Thank you for watching the video.